The ground beneath our feet is the surface of a planet whirling at thousands of miles an hour around a distant sun. Our life is possible only because of the light and warmth of that sun, a star. Yet the sun which shines on us is only one out of billions of such stars in the universe. This is one of the world's major observatories, the David Dunlap Observatory, 15 miles north of Toronto. Dr. Donald McCrae is a professor of astronomy at the University of Toronto.
Observatory.
At any moment, scattered throughout the world, there are hundreds of men and women observing the heavens with optical and radio telescopes, gathering data for the solution of many questions about the universe. Routine work for the most part. McCrae's job tonight, if the sky remains clear, will be to take photographs of 6 stars with the telescope. A mirror over 6 feet in diameter, with its surface shaped to within 1/millionth of an inch, will catch the light from a star. This light will be reflected from the large mirror onto a smaller one, which in turn will focus it back into a camera at the base of the telescope. Out of the study of hundreds of thousands of observations, astronomers have pieced together an accurate picture of the universe. Beyond the appearance of starshine and moonbeam, what will the first men to leave the Earth find? Enough is now known that we can, in imagination, journey into these spaces. 250,000 miles away, the moon. This is the moon that men have worshipped as a goddess, that countless lovers have sighed over and sworn by. It will take immense courage to journey to this place, for on this pitted and pocked ball of pumice and stone, there is no atmosphere, no air to breathe, no sound to hear. By day, the sun's heat would boil water, if there were water. At night, 240 degrees below zero. Unshielded, a man couldn't live here for 2 minutes. But if he were to die, his body would lie unchanged through thousands of years, for nothing grows and nothing decays. If you were to hover in space beyond the moon, speeding up in imagination its movement, you would see a majestic procession in the sky. As the moon circles the Earth, so the Earth itself circles the sun. The sun is the center of a system of 9 heavenly bodies, called planets, which wheel around it in vast orbits, trapped by its gravitational pull. Closest to it, the tiny planet, Mercury. On the surface of Mercury, the temperature is hot enough to melt lead, for one face of it is turned perpetually to the sun, only 36 million miles away. If we looked outward from Mercury, we would see the second closest planet, Venus, shining brighter than the much more distant stars. Venus, in orbit 31 million miles further out from the sun, is a mystery, for its face is veiled by dust storms, or perhaps dense cloud. Looking outward from Venus, the most brilliant and beautiful object in the sky would be a planet in orbit 25 million miles still further out, Earth. Beyond Earth, shining redly in the night, Mars. Colder than Earth and smaller, this is the planet men have looked on and wondered whether they are alone in the heavens. It is reasonably certain that the markings on its surface, bluish green in the Martian summer, turning rusty brown in the autumn, indicate vegetation. Here, however, the atmosphere has almost no oxygen, and no creatures like men could live here, 140 million miles from the sun. In the place past Mars, where there should theoretically be a planet, there are only the asteroids, small bodies ranging from boulders to chunks 300 miles across, hundreds of them swinging in orbit about the sun. "500 million miles out from the sun, the giant planet Jupiter, ruling 12 moons. Jupiter, seen here from one of its moons, is larger than all the other planets put together. Its atmosphere is 1,000 miles deep, a poisonous mixture of methane gas, ammonia, and hydrogen, which at the bottom must have the density of water. Here, under the enormous pressure of the atmosphere, a human being would be crushed beyond recognition. These are the rings of Saturn, bands 10,000 miles wide, composed of almost an infinity of meteoric particles of gravel and ice circling the sixth planet. Saturn, with its 9 moons, is so far from the Sun that it takes 30 Earth years to circle it. And here the temperature never rises above 240 degrees below zero. And if we were to plunge still further out, hundreds of millions of miles, past the planet Uranus, beyond Neptune, we would finally come to the last of the known planets, to the dwarf Pluto, named for the god of the underworld. Its surface moves in perpetual darkness and unimaginable cold, for the sun is 4 billion miles away, only a starry speck in the sky. Sometimes a strange apparition appears in the sky, a comet. Like a planet, a comet orbits the sun, but it is only a loose conglomeration of ice and dust, invisible, until its head comes close enough to the sun, whose rays then excite it into fluorescence, and push away from the head a vaporous tail, which may become 1,000,000 miles long. For a few weeks, a comet blossoms, and then, passing the sun, it will fade and coast again, unseen, billions of miles into the darkness, perhaps not to return for a century to the blazing star, which is its master. The sun is an unimaginable inferno, a thermonuclear furnace churning with the storms we see as sunspots, heaving from its surface columns of gas that arch 300,000 miles into space, pulled and twisted by enormous electrical and magnetic fields. The sun produces the energy of 1,000,000 hydrogen bombs exploding every second. So it has raged for 5 billion years, and so it will rage for perhaps another 5 billion years, flooding its planets with radiant energy. Too near or too far from this furnace, instant death for men. Between 91 and 93 million miles from this star, filtered through a blanket of atmosphere, its energies sustain human life.
Ehrenborn, writer and president of the Yucatan
Man ist vorsichtig geworden, gewiss, und man ist dadurch realistischer und illusionsloser geworden.
Hey, what's the matter? You're just trying to...
When a particular star is to be photographed, it is located by its coordinates on a star chart. On such a chart, every black speck is a star.
14.6.7 plus 13.49.
"45 tons of steel and glass must be aimed precisely at a spot perhaps 200 million billion miles away. Many of the stars astronomers study are invisible to the naked eye. Even the nearest ones, apart from our sun, are so far away that their light is very dim. The mirror in the base of the telescope gathers and focuses hundreds of thousands of times the amount of light seen by the naked eye. Almost nothing of a star can be known directly. It is a photograph that is studied. Not a portrait of a star, but a photograph of its light, split into a spectrum in which each band has its meaning. The presence in that distant star of elements like iron, calcium, carbon. From a spectroscopic photograph, astronomers can tell whether a star is moving towards us or away, by exposing on the same plate the spectrum of the star and the spectrum of an iron arc, and measuring the displacement between the two. To photograph the spectrum of the arc takes 10 seconds. To catch enough of the light from the star may take up to 2 hours. During the exposure, machinery in the base of the telescope automatically compensates for the rotation of the Earth, keeping the star centered. If we looked more deeply into space, leaving behind us the Earth and the whole of our solar system, and traveled at the speed of light, it would take 4 years before we came to even the closest of the billions of suns scattered through stellar space. Although the stars are suns, many of them are unlike our sun. Some, like Beta in the constellation Lyra, instead of planets, have a second sun swinging around them. There are multiple suns, like Castor in the constellation Gemini. There are giant suns 5,000 times as large as ours, and dwarfs in which 1 cubic inch of matter weighs 40 tons. Suns rotating so rapidly that pinwheels of gas are thrown off, weighing more than our whole system of planets. Suns that over a period of days or hours pulse as their internal nuclear processes change. Rare suns in which the temperature reaches 5 billion degrees, where nuclear fusion makes elements as heavy as iron and results in the enormous explosion of a nova or supernova. The brilliant light from such explosions floods through the gaseous clouds of space for billions on billions of miles. And the remains of a supernova recorded 10 centuries ago can still be seen as the Crab Nebula in the constellation Taurus. As well as stars, in stellar space there is gas and dust, sometimes glowing in starlight, sometimes dark, obscuring what is behind them. Stars, gas, dust, all moving in apparent chaos. Until a generation ago, it seemed indecipherable. The only suggestion of form was their grouping in the band we know as the Milky Way.
Dr. McCrae? HD 303.
Now, years of patient work have revealed a pattern in the universe. A pattern beyond anything we could have imagined looking at the heavens with the naked eye. With data sifted from countless painstaking observations, astronomers are now filling in the details of a pattern so vast that everyday ideas of distance and time cannot encompass it. If we could move with the freedom of a god, so that 1,000,000 years pass in a second, and if we went far enough, past the nearest suns, beyond the star clouds and nebulae, in time they would end, and as if moving out from behind a curtain, we would come to an endless sea of night. In that sea are islands, continents of stars, that we have named the galaxies. The largest known forms in the universe, hundreds of billions of suns bound together by gravity, rotating around their common center once in 200 million years. Our sun, with its planets, is near the edge of one such galaxy, the rim of which we see dimly as the Milky Way. The galaxies are the birthplace and graveyard of the stars. Here, gas contracts into knots, becomes hot, and flares into the life of a sun, sometimes forming with it planets, sometimes planets which must be suitable for life. And here too the stars finally consume themselves and collapse into cold, dark dwarfs. A 100 billion suns, yet forms so enormous that they have been observed slipping through one another like phantoms, their stars light years apart, continuing undisturbed in their courses. At the very limit of our most powerful instruments, galaxies still are flung across space, themselves as numerous as stars in the night sky. But when we look this deeply into space, we are looking at a ghostly image of the distant past, for the light by which we see these regions started traveling towards us long before the dawn of life on Earth. In all of time, on all the planets of all the galaxies in space, what civilizations have risen, looked into the night, seen what we see, asked the questions that we ask?